Okay, hello everyone, welcome back to another video. Here we are going to solve another problem which is 2086b, and it is again an 1100 rated problem. Why not am I moving uh, to a different difficulty level? Because that's my actual uh, potential barrier. Like I can only solve 100 to 1100 rated problem right now. I tried 1200, but it was difficult for me back then. Like I'm trying to get more comfortable with 1100 problem, and then I want to switch to 1200. Let's see this problem. Also, there is a new setup where I'll be explaining my thought via this writing. So wait, yeah. So this is a problem 2086b, and and the problem name is large array and segments. So there is an array consisting of n positive numbers and positive integer k. So there is an array A with n positive numbers and an integer k. An array B is created from A according to the following rules, and the rules are: B contains n into k numbers. Secondly, the first n numbers of B are same as of A. That is, we can say Bi is equal to Ai for all I less than or equal to n. Then third is, for any I greater than n, Bi is Bi minus n. So we're saying that given a number x, it is required to count the number of such positions L, where L belongs from 1 to less than equal to n dot k, for which there exists a position R such that R is greater than or equal to L, such that the sum of elements of B on segment L to R is at least x. It is at least x, or maybe greater than that. This is what we need to find out. Okay. So this is what my information. This is how I note my information, and do let me know if there is a better, simpler way. Like, this is how I think I note down every important thing which is given in the question. Uh, Okay, this is the main crux. We're given array A n who has n positive numbers and an integer k. Array B is created from A. B contains these numbers, and then Bi is this, and this is how B is created. Given a number x, it is required to count the number of such positions L for which a position R for which there exists a position R such that the sum of these elements between L to R is at least x. Okay. Firstly, let's talk about array A. Let's say it has A1, A2, A3, A4, and so on till AN. What about B? B will have A1, A2, A3, and so on till AN, right? Then it is given that for I greater than n, Bi will be Bi minus n. So now Bn plus 1 will be B1, Bn plus 2 will be B2, and so on. So again A1, A2, A3, and so on till whatever n into k is. We'll keep repeating this until we are at the final position. So basically Bn into k will be Bn into k minus n, right? Okay. We'll keep repeating it, right? So once array A is completed till an, then again these numbers are repeated until the length of D is over, like n into k. It reaches n into k. Okay, so the we'll see 2314, then 2314, and 2314. If k was 3, because 3 4 are 12. Yeah. So if k is 1, see, one observation is that k is always greater than 1 and maybe 10 to the power 5, whatever it means, right? So one observation is that one observation is if k is any number y, let's say, let's assume, then k is what? What we can say about k? How many times b will repeat the array, right? How many times do you think b will repeat itself? So that would be that b repeats array a k times, k or any number, k times. That's it. That's what we have in our mind, right? So okay, now we are given a number x, right? We're given a number x, and that number can be greater than or equal to 1 till less than or equal to 10 power 18. Okay, and we have to just count so the number of suitable positions such that L and Huh. So Once we find that suitable position, such that now you know there exists in a such that the sum of these limits. So we just need to find that L. Okay, there exists an R. So for which we have got to count number of positions, such positions L, for which there exists position R, such that the elements of array B on the segment L to R is at least sum of the elements is at least greater than equal to X. Okay, so how is the second one? There are 12 positions. Hmm. Why isn't that? Can we say? Can you just say that one if L is here and R can be this also, this also? Like I'm a bit skeptical. There are 12 positions L for which there exists a suitable position. What do you mean? Okay, yeah, I understand because fine, fine, fine. We'll multiply n into k, and that's why there will be multiple. Like there will be it will be such a large array, right? So that's what my point was. That if we notice n into k could be very large, right? And n into k would be very large. So there is no point of creating b. There is no point of creating b. That's what my point was. We just need a little observation. I feel this is the first time I'm solving the question, so maybe I could be wrong. But let's see. A1, A2, A3, A3, A4, and so on. Right? Okay, till an. So this is case one, where in array A itself there lies a position L, such that after there exists position R, for which the sum is greater than or equal to X. So in array A itself there is a position. Array A itself there is a position L. So let's say that position is at this index. This is what L is, and after that there exists a position R. So if नहीं, but what if सबसे छोटा index will be L, no? Because if this is L, then what if then we'll move forward and we'll find कि अच्छा इसका देख लेते हैं. then we'll say कि अच्छा this can also be L. Then what if we'll check A3 से लेके बाकी सब के यहाँ पे R रख के, because all are positive, right? तो we can say अच्छा ये भी L हो सकता है, then अच्छा ये भी L हो सकता है. फिर एक कोई पॉइंट आएगा जहाँ पे इससे आगे अगर L आता है, then this sum will be less than X. So वो L हम नहीं लेंगे, तो इतने L हम ऐड कर लेंगे. तो ये जो नंबर होगा, नंबर ऑफ इंडेक्सेस, indices, whatever the spelling is, will be, let's say y, let's say. So अब what we can say is that when you'll repeat, no, when there is like a repetition, a1 a2 a3 till an, फिर again a1 a2 a3 till an, और ऐसे k times चलते रहेगा. In case of b, this is array b, this is the array b. So now what we can say is कि uh, now what we can say is that uh, देखो यहाँ से L was always an answer और वो k times चल रहा है. तो my answer can be, my answer तब वो यहाँ से भी हो सकता है, अब वो वहाँ से भी हो सकता है. तो ये पूरा, अब जब ये यहाँ से यहाँ तक भी अगर सम जो है वो ग्रेटर देन x है, ग्रेटर देन इक्वल टू x है, तब वो सारे, अगर if this is true, then this whole चीज is true, and plus now this is also true. कब तक? till the point कि ये the last pair, the last segment which will be ai a2 and so on then an, वहाँ का ये L, वहाँ का ये L and so on जहाँ रुकता है वहाँ तक ये हो सकता है. तो like it's like n into k minus 1. These all can be the probable indices for L, plus wherever this L is now, after this, if you'll choose an L, then the sum is like less than X. तो वहाँ तक, तो just first find कि till where we can say in array A कि we have got our answer. So this is the first case, plus y, because this is what it is. So this is case 1. This is case 1. And let's cross check it with a given example. Let's say we have 5 and 3 and this 10. Okay. So we have got 3, 4, 2, 1, 5. We can definitely have an L here. We can definitely have an L here because 4 plus 2, 6 plus 1, 7, 12. Can we have an L here? No, because 2 plus 1, 3. Oh, sorry, I'm not showing it right. 2 plus 1, 3, and 2 plus, and then it is 5, so 8. So we can't have an L here. So only these two places we can have our L. But k is what? K in our given example is 3, right? So k is 3 and x was 10. So obviously we can say ki 3, right? So n, and n is 5. So 5 into 3 minus 1 plus these two places gives us our answer, and that is 12. Is it the correct answer? Yes, it is, because see, this answer is 12. Right? Okay, great, good. So far, so good. We have actually thought, like our thought process is in the right direction. Now let's talk about case 2, where no indices in A exceeds in A says I'm very sorry guys, I'm not good with English. How to put it? Like, no indices in A can be a good choice for L. So like there is no good choice for L. So that means that even even if you choose this, the sum of like this, all the AI where I is varying from 1 to n is actually less than x. There is no such good a L possible. This is case 2. If this is the case, if this is the case, then we need, we need the repetition of B to to just handle the case, like till where we are we look at the problem where we are talking about this array, and now we'll try to find, is it possible, guys, to have an L now in this case, so that I put my L, and now all the sums are greater than or equal to x. So in this case, I'll see that, okay, fine, now I'll put this L, and whatever the sum is, let's say the sum is S. This is S, and this is S. So 2 times of S. Is it greater than or equal to x? If yes, then we have got our first L here, right? Then we'll check for this, we'll check for this, we'll check for this, and so on till we say ki 2s is our new array. And now we'll check whatever we did for this case. Now we just took one single segment of like a array, and we did for that, and we arrived to this formula. We'll create the same formula, but now our whole one array is just 2 times of array a, right? So now we'll have to create another formula for which this is the case, but it's not necessary that 2s will always be the like will give us the answer. So we need to have a generalized form. Let's say we get our first L at alpha. I'll not try to introduce that. I hate this variable. What else variable do we have? Mth time. So m into s is greater than or equal to this is the case, and m can simply be formed like x by s we'll do, and we'll calculate the seal of it. This will be our m. If m is greater than k, then return -1, because return 0. since there is no, okay, 0, -1, no index of L possible, right? But if M is less than or equal to K, then you know what you have to do. It's just AN, A2, A3, and so on till AN, where A1, A2, A3, so on till AN. And this M times we need to do. And we've got our first L. Then we'll check, is this fine? Is this fine? And there will be a stop. So that stop will come when, do we need to, that stop will probably come within this region itself. Like you don't need to go over here. You will find it at the very first, like in the very first beginning. So you'll keep on subtracting m into s minus a1. Then you will say do m into s minus a1 minus a2 minus this until this happens. And the moment this happens, you'll not catch how only L can only go till that place. And if that's the case, then fine. I've noted all the points. Now m into s may, you can only go up to, let's say, fourth index. Fourth index that you can only go. Then how many times m into s appears in the k times, right? So you need to ask yourself that, you know what, how many times k into n may say m times we repeat. Like that's the one segment. How many times that segment repeat itself? A repeats. Our answer array single unit length. This is the length of our answer array. So let's see with the given example 1, 2, 3. K is, let's say, 5 and x is, let's say, 7. Let's say 10, or maybe not 10, 15. Okay. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. This is 5 times we repeated. Now, if you check this, the sum is 6, right? Sum is 6. If you did sum 15 is equals to sum, wait, x is equals to, needs to be, we need to have this sum into m. M will be nothing but x by s. So m is 15 by 6, and that is 2 point something. So m is 3. Okay. So we need 3 units, right? So we'll come at this and we'll say, ki, acha, fine. This sum is 6 into 3, that is 18. Then we'll come to this L and we'll say, ki, we just subtracted 1, right? So we got 17. Okay, sorry the recording stopped. My bad. We'll continue from where we left. So we are here, and I was thinking that how to address this problem. That okay, fine. Uh, we are here, and now if you move further, the sum will be less than x. So now this is our actual array answer array for the first time we found n. How many times this repeats itself? That's the question. Probably one, because if it doesn't repeat itself again, because these are only two length, like the two times, and these are three repetitions of array A. So this is how we did the first one. Okay, so this time we need to see till what length, till what L we can find our answer. And the moment, let's say it broke here, so how many times this segment repeats itself? For example, here this segment, how many times it repeats itself after having this? So I would say ki if I leave this and I come here, I need to have this, right? So let's say in our answer array, 1 2 3 1 2 3 1 2 3, we got our L till here. Now how many times this unit repeats itself? So we see two times, because in my given example, this unit repeat itself two times. So now I can say that if in order to get L here, I need to take consideration of this. And in order to get L here, I need to have a consideration of this and then this. So now how many times I can have L? My answer L will be 1 2 3. And how many times this repeats after this? After this, how many times it repeats? So it repeats two more times. Two more times. So once. So how did we conclude this? Once we calculated M. Once we calculated M, which is the minimum repetition of A such that the sum becomes greater than or equals to X. Please note this point. Whatever I said, minimum number of repetitions of array A, such that the sum, this whole sum becomes just greater than X, greater or equal to X. How many times this one repeat? This whole one repeats. So how many times one, and then again one, two more times. So my answer will be L is equals to this 3 plus how many times it repeats again. So 2 times of 3. and L will be less than n, less than or equal to n. It won't be greater than that. Like it's not possible ki in one answer array, this is answer array, so it's not possible ki L will be till here and then this unit we need to find how many times it is being repeated. No, that's not the case, don't worry about that. It will be at least less than, because this formula ensures that L will be ending up here itself, right? So that's the thing, that's the thing. So this is 18, and till here we can have our answer. The moment you go here, the moment you come here, that's still less than 18 minus some one some you. Okay, fine. We are safe. We are safe. So what we can finally say is that now L will be uh, now the number, now our count will be n into m times. So our first answer array was this k minus m. Let's see. N is what? 3 into k was 5 and m was 3 plus 1. Like, let's see if it's correct. I feel it is. Like, we have mathematically derived it. So, what are the input? N, K, X. We'll try to have it in long. Fine. Okay. Now, here itself, we'll calculate some also. Okay. Right. Fine. Now, let's talk about case 1, where if sum is already greater than or equal to x. If that's the case, sum is already greater than or equal to x. You need to find till when our sum. So int L count this. Right. So for int I equals 0, I less than n, I plus plus, you know, uh, ai l f count is already 1 because first element, first index, though it will always be U. It can always be L, right? Because sum is itself greater than equal to X. So count is already 1. Now we'll go to this. Sum minus AI minus 1 greater than equal to X, then count plus plus. Right? So this is less than equal to so count plus plus. Count will be increased. Okay, right? So till when it will be. So coming back to our formula that we derived, this formula we know till what value. So this is the y is the count variable, and now we know the answer. So we can simply say C out is n into k minus 1 plus count and then continue. Oh wait, what? Answer is 15, right? This whole can be true. Then so 4 plus 2 plus 1 7 12. 7 to 9 9 10 15. Oh yeah, my bad. This statement is wrong. We need to continuously update it. No answer. So that's our first case. Now the second case is sum is less than x. And in this case what we need to do is we need to define a variable m, and this m will be seal of seal of what? Seal of x by sum and we have calculated m. Let's have another example to cross check our answer. Let's say we have 1 2 3 5 2 1, and then k is, let's say, 6. So 3 5 2 1, 3 5 2 1, 3 5 2 1. That's 4 of 4 times, right? 3 5 2 1, and then again 3 5 2 1. And our answer is 8 10 11 11. So it's 22. 21. So this sum is 11. M will be 21 by 11 ka seal, that is 2. So we need to consider 2 times of this array. This will be our answer array. Now what we need to do is we need to check if yeah, we need to check till when we can have our answer. So the sum is here 22 for our answer array. This answer array ka sum is 22 right now. So if we remove this, we are here. Then let's say we are here. Then 22 minus 3 is something like 19. So that's less than x. How many times this 3 appears? The question. Like in order to remove this 5, I need, in order to remove this 3, I need a 3. So now my answer array will be this, to remove this. In order to remove 5, I need to have this. How many still can't remove this index? B1 in for my answer array. So K is what? 6, 2, plus 1. And this formula is wrong. I need to find till which m this answer, this L repeats itself. So L is 1. This is why in my case. Oh no, it is actually correct or what? Let's see. 4. Wait, I'm having a call, but I think we are verge of solving it. Okay, okay, we are continuing. Sorry, I had to stop because I got a call, but we're continuing. We're continuing. So, is this formula correct or is this formula correct? That we need to find out. And we found out, like, I think we are very close to our answer. So, let's say that if sum was less than x, we needed to find the minimum times a needs to be repeated, and that is m times, so that the sum is just greater than x. If that happened, now we'll find L. Now we'll find L such that at that particular L we discard this, and once we discard this, our sum will be less than x. So if we discard this 3, we need to expand our answer array, and then we need to include this 3. That's the only way we can discard this 3, right? That's the only way. So we'll find till where we can have our L, and further if we can't have our L, we need how many times we can repeat the same thing, right? So how many times we can actually do it, like, in order to get L here we need to expand our this, in order to get L here we need to expand our this, in order to get L here we need to expand our this, then in order to get L here we need to expand, right? That's the thing. Okay, now how many times do we have to do that? That's the question. How many times do we have to do that? Isn't it k minus m times into all the possible positions? So now L can be this, L can be this, L can be this, L can be this, and then this will, when L reaches here, now this whole is our answer array. This whole is our answer array. Yeah, this and this and this, and once L reaches here, this whole is our answer array, and L reaches this right here, and L reaches this, and then this, and then this whole is our answer array. So how many points? 4 plus 4 plus 4 plus 4, and that gives us 20. And once we get here, once we get here, uh, that's 21, right? N into k minus 1, k minus n plus 1. Does it apply here too? Let's see. N into k minus m plus 1. That gives us 7. 1, 2, 3. 6, 7, 8, 9. Hmm, I can't actually, like, there is some error. We need to think clearly once again. If L goes here, we need to include this. If L goes here, we need to include this. If L goes here, we need to include this in order to have our sum greater than or equal to x. So L equals to n values. We need to include this, this, and this. So this is n, this is n, this is n, this is n. If you go till here, then this needs to be included. So we have got n. So 1, 2, 3, 4. So 1, 2, 3, 4. So if in order to have this is set, and if this gets over and comes here, then this gets over and comes here, this is our set now. Sorry. uh, the first element is there, then definitely the whole element is different. K minus K minus 1 to 0. सोलह, यहाँ तक 16 पॉइंट्स हो गए। जैसे ये यहाँ आएगा 17 हो जाएगा। सिमिलरली अगर हम 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 वाले एग्जाम्पल लेके बात करें, ये वाला एग्जाम्पल जो था जहाँ के 5 था m3 था, क्योंकि सम कितना था x हमने कितना दिया था, x 15 दिया था, फिफ्टीन बाई 5 सॉरी 15 by 6, m was 3, राइट। तो ये एल हो सकता था, ये एल हो सकता था, ये हो सकता था। द मोमेंट जब एल यहाँ आता हमें इसे ऐड करना पड़ता, यहाँ पे y जो है ये चीज हाउ मेनी टाइम इट रिपीट इटसेल्फ देखनी है। 2 टाइम्स इट रिपीट्स। ये नहीं कह सकते ना, +2 बिकॉज y के जो वैलिड पॉइंट्स हैं वो 2 हैं। इफ यू सी वैलिड पॉइंट्स पता लगाओ, y कैन बी 1 और 2 इन द गिवन एरिया। इस एग्जांपल में हमारे वैलिड पॉइंट्स जो थे वो जस्ट 1 था, उसके बाद हमें एक्सपैंड करना पड़ा। कहाँ एक्सपैंड करना पड़ रहा है, एट विच पॉइंट वी नीड टू एक्सपैंड, you'll stop there, you'll stop your valid point counting then and there itself, ठीक है। तो ये जो n इंटू के माइनस एम है ये तो चलो से फिक्स है, ये जो y करेंगे हम यहाँ पे वैलिड पॉइंट्स इन आवर आंसर एरे का काम करेगा। देखो दैट इज व्हाई यू विल नोटिस कि 4 इंटू 6 माइनस 2 प्लस 1 17. यहाँ पे 3 into 5 - 3 + 2. Sorry, valid points can be 3 till 3 as 3 को हटा नहीं सकते ना, चलिए L can be till here. So valid points are 3. That is why it's 9. The number of valid points we need to calculate. Okay, got it. वैलिड पॉइंट एक तो है ही. Remove that valid point plus and then see out into k minus n plus valid points okay, wait, 12 1 4 5 2 1 8 8. This is wrong. Minus 1. So let's see why it minus 1. So the test case 215, we have got or we have 2 and 1. 2 and 1 is our answer array in this A array. Okay. K is greater than or equal to. Do this. Else see out. It's just everything is matching except this, right? Why is it this? Why is it like? Why is this happening? Long in our formula is pretty much good, isn't it? 4, 6, 21, 3, 5. What was it? 3521. 3, 5, 15. Wait, what? 3, 5, 15 is x. 7. Why 7? N is 3, k is 5, x is 15. It's 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 3. M is 3 then. Valid points are 3. 3 into k minus. Wait, it should be 9, right? Is this part not happening good? Like, what if I just comment them down and just sc out M 3, 5, 15, 1, 2. M is 3, right? It's correct. It's correct. Hmm. Then what's the issue? Okay, sorry, the recording stopped again in the middle where I did the actual main thing, and that was nothing but introducing this new sum variable. Uh, I thought that it was recording and I explained everything. Like, this was the only mistake I was doing. Like, I initially, like previously, I did not do this, and so there will be new sum here, and then we need to check this one here, and then we need to solve all these equations, and then we'll get our answer. And it is correct. It is getting submitted. So yeah, that's it. Thank you for watching.